Hi, today I would like to show you how to set up continuous integration and continuous delivery that we're going to require in order to build Docker containers that we are later on pushing to Google Cloud or AWS. So this is actually the overall goal, that we're able to build containers that contain our business logic and then are pushed later to Docker registries in the cloud, where they later will run on container orchestration systems like Elastic Container Service on AWS or Kubernetes. So where do we start? Um, for the beginning, we separate the network, which is actually the internal one, and the external one. What we are going to require is actually build hosts that should run Linux. That will be able to spin Docker containers in which we are going to run our builds. So why don't we run our builds on bare virtual machines? Because we always want to have a fresh setup where we are working with our builds and creating our builds in a fresh environment, so that in case something broke during the last build and the machine was not cleaned up properly, so that we are not going to have impact on another build. So this a Linux host, there can be multiple of them, and they are configured that way that they are actually able to spin containers which will be used to run our builds inside. Secondly, we are going to need a source code management system. This will be usually a Git. That will contain our code that we are going to want to build. As a second component, we are going to need a CI server that is going to pull the code after every push or every commit, and that's going to spin up one of the containers that we have defined somehow in here. Tells the container, take the code, take the CI script, run your build, and then ship the artifact to an artifact repository. Artifact repo. So we're running the build, and out of the build, we're pushing something to the artifact repo. So this is like a quite simple component, and of course, there, as the artifacts of our build might be a container, this is going to go to the Elastic Container Registry if we're running on AWS, or it's going to, I don't know, Kubernetes registry if we're running on Google Cloud. So during the build itself, we are also required to use other dependencies, like our builds that run inside here, and the builds will be based mainly on Java, so we will use Maven or Gradle in order to run our builds. Systems like Maven and Gradle, they handle our dependency management. So we're not writing every single line of code in our applications ourselves, so we're using dependency on code that's already available outside, and artifacts that we are used that somebody else has already provided. So during our build, we will also use artifacts that already exist, and our artifact repo is going to talk to like Maven Central, and if our build requests an artifact that's not already within here, it's going to talk to Maven Central, pull the artifact, store it in here, so it will be available for the next build. The same thing is actually true for Docker itself. So if we are building a Docker image inside, the base images that we're using, like if we're using CentOS or Ubuntu or Red Hat or things like that, we are not engineering all those images from scratch ourselves. So we're using things like from other Docker registries. So we're pulling stuff from, for example, Docker Hub. So the artifact repo is going to pull things from Docker Hub, stored locally, and if it's later on required during the build, it's like only pulled from the artifact repo. So Communication outside to Maven Central or Docker repository is usually done through HTTP or HTTPS. So those ports would need to be opened on the firewall if necessary. Attached here, we will need some storage in order to have all dependencies that we need for our build are stored inside here, as well as something for the Docker containers to be held as well. In order to get some more security inside here, we would like to use the Artifact wrapper as kind of a firewall for all the dependencies that we're using. So dependencies that are fetched should be scanned, and also should look into if license file are in there. So if we're fetching dependencies that don't meet our license requirements, it should be rejected and the build should not go through. So what can you do in order to do that one? Actually, for the Artifact repository, there are commercial products outside like Sonatype Nexus and JFrog Artifactory. Both of them can run on-prem, and they come with tools like X-Ray, or they come with IQ Server. And those components do the scanning for you. You can configure them so that you don't fetch malicious Docker images like the one that was like on the news recently that started Bitcoin mining on your hosts, as well as that you fetch maybe dependencies that should not are under licenses that you don't want to use. So this should be configured properly. So when we are now coming to a more concrete implementation when it comes to source control, when you look at those, you could either use, like, for example, Bitbucket if you're the Atlassian suite, or you could use like GitLab. So as they are both running on-prem, which stores all the code inside. It will have something on top like a nice GUI for user management and stuff like that. Also for ticket management and code reviews that should be done within your source code management system. So you probably also want to hook that up to your Active Directory or LDAP so that user management is consistent. So developers will pull and push code in there, and you also might hook up it to your knowledge system like Jira, Confluence, CollabNet, or whatever you have in place at the moment, so that you have a consistency in there. So within there, you will need several repositories where you store all your code of the application, and multiple people inside your network, as well as outside your network, should be able to pull and push code inside there. Although I know this might be somehow critical, but if you're working with external vendors, you need to have some way of having an interaction with your source code repositories. So that should somehow be feasible. So now you have all the code and it's all there, but you want to make sure that it builds and runs and ships an artifact that can go to production. So you want to have a CI server, like it could be Bamboo, could be Jenkins, could be, I don't know, Circle CI, could be GitLab CI. And what they are doing actually, they're constantly checking the Git if something changes, if code was pushed, and they get notified, get the events from Git. And based on the configuration that's within the repository, like the CI file, I'll call it, it's like the information on how the build should be run, the CI server decides what to do. So for example, if it says, okay, build every push with a certain script, then after a developer pushes code to the repository, the CI server gets the event that an event has happened on the Git. So the CI server is going to pull the code. At least it pulls first the CI file out of the repository, decides what to do. Within the CI file, it will say something like, for our build, we would like to spin a container on our build machines, and that's an image actually that contains Linux, it contains Java, it contains Maven, and it contains already also some configuration that it knows how do I speak to my artifact repo. So it will need some kind of settings, XML. And the second step, it also will need some kind of information on how to authenticate against other other registry that will run outside your on-premise system. So it will need some passwords and keys. We don't want to store all the keys or the settings within our source code because this is something you don't do. We will need some mechanism so that depending on which repository is used, that those information is injected and is stored somewhere either on your Linux host and is only accessible by sudo, or it's somewhere else stored on a dedicated machine that holds all the credentials. There you could use some vault system like HashiCorp Vault, and based on the container that is spinned by your CI, those information should be injected so that they are only available at build time. So now based on the CI file, our CI server has spinned a container up that is fresh for our build, fresh from scratch, and it's going to check out my code in there. Well, I just write down Java code because that's quite common that we're going to use that one. And then within the CI file, there will be some steps that will need to be taken. For example, it says like Maven clean install, so that out of the code, we're generating a jar file or a WAR file. During this step, actually, we're going to fetch various other jar files, like for, I don't know, logging, or it's using Spring Boot as your runtime framework. So it's going to pull all those inside, run the build inside there, and it's the artifact is maybe a jar file, and you just, for simplicity reason, you store it there as well. So now we have the jar file. It's the running application that will be later on go into a Docker container. So as a second step of our CI process, we maybe want to run a different container, as out of that file, out of that build step, we are not going to generate a jar file, but we're going to build another Docker container. So what this Docker container needs to be able to do, it needs to run Docker within Docker. So for the second build step, actually the CI server says, okay, spin, for example, Docker latest. Docker latest is an image that contains Docker itself again. And in this case, I'm, for example, checking now out the Docker file. That's also stored within my source code repository. And here I will not run something like Maven clean install, but more I would like to do something Docker login. So I'm going to log into the local registry. Then I will do Docker build, Docker tag, and then I will push the Docker container here. And I will do the same steps for actually pushing my container to AWS. So running Docker in Docker is not rocket science, but there is something you might want to look in. In order to do that, you need to share Docker sock with your container so that you can use actually Docker in Docker, or you use Docker dint that will also enable you to use the Docker in Docker thing. And if we have accomplished all those steps, we're actually good, because out of a build file, out of our source code that contains Java, the Docker file, the CI file, our CI server is able to spin up the Docker containers that take up our different build tasks. We even could have additional tasks, like for if we just want to interact with our cloud service. This is a dedicated container that only contains the AWS CLI and the dedicated credentials for it. So you don't want to have one simple Docker container that does all your builds. So you want to have maybe one container that does all your Java builds, one that does all your Android builds. Then you have one that does the Docker and Docker builds. Usually it turns out that having the code build and the Docker and Docker build is usually one container, so that's quite straightforward. You ship the artifact, and as soon as you ship the artifact up here, you also might want to have your AWS credentials inside here. So this is actually how the whole integration works. So what are usually the critical points that you want to look at? I would like to highlight them again. So we are going to need source code repository like Bitbucket, getting access to it like from internal as well as from external systems, having it hooked up to AD so that authentication is already done in a nice way. Pushing code can be either done through HTTP, HTTPS of course, or SSL. That is what Git supports. We will need a build server, which is able to be configured and accessed already by developers. in case you want to modify your build, you should be able to get access here. So you want to hook it up to the Active Directory as well. Then what we need is like you will have several build hosts. These will be usually virtual machines that run Linux, because running Docker containers on Linux is the most logical thing you could do. And on those Linux hosts, there will be build agent that will continuously talk to your build server. It's like agent or nodes or whatever, or runners, how they are called. And so in this case, Bamboo knows, well, there are 4 hosts, and on those 4 hosts, I'm able to have either like Docker runners, or I'll run my runners on bare metal or whatever. We want to have them in Docker images because that turned out to be helpful. So need to be able to spin containers here that run our builds. So this is depending on how which product you're using. Could be, well, Bamboo, Jenkins, GitLab CI, Circle CI, you name it, will be a different mechanism. And out of that, we are pushing it to the Artifact repository, which of course is going to be hooked up to your Active Directory, LDAP, whatever, because dedicated users will do the push. So what we also will need, we will need some service users, because the build runner inside here that does the pull and the push of the artifacts and the Docker images will need to authenticate against the repository inside here. Usually authentication for pulling from Docker Hub or pulling from Maven Central is not necessary, is not required. This is something, a feature that's called proxy. So we're proxying those informations into your artifact repository. And last but not least, what we need to define is like that we are able to do those Docker and Docker builds. This is usually something you want to discuss with security. You will need to handle it somehow, because if you can't do that, you cannot do Docker builds. And doing Docker builds on your native machines is also not what you want, because then you have lots of Docker images on your machine that you need to be cleaning up all the time. That's another good point. Like, you need to have also cron jobs that make sure that like disks are not running full. You're monitoring all those nodes. Maybe also piping the log output to some Elastic Stack so they can get some metrics out of it. So that's not a requirement, but a nice to have. But you need to run cron jobs here to clean up all the Docker images. What's not good purpose is like, say, clean all Docker images up at midnight, because if we are running 1,000 builds with 200 different build containers every day, there will be lots of traffic inside here. So you want to make sure that all Docker images will be cleaned after some time. So basically that's it. We are having communication between the build server, between the build Docker containers and the artifact. Usually is done also through HTTP, HTTPS. So that's good from a firewalling perspective. And yeah, of course, you need the repository on-prem, should be close to all the build servers so that the builds run quick. You don't want to have that one in the clouds and run your build on-prem, because you have a lot of traffic, a lot of latency, and a lot of volume that's going back and forth. So that makes builds slow. Slow builds are not what we want. Yeah, make sure you configure IQ Server or Xray probably, so that you allow only things that you would like to allow. What we also will actually do is like, say, the build images that we're using for building will be also stored inside the repository. So there will be also some authentication within your build server like Bamboo, that it knows in order to build, for example, a Maven container that's going to be used for a build, I'm fetching it from here. So there will be some relation between those two here in order to tell a Linux machine, take the container from here, spin it, pull the code, and do it like that. So, looks a bit complicated on the first step. If you have your components in place, source code management, CI, repositories, build servers, you're good. Make sure you get user management right. Make sure you have service users for the builds. Make sure you have firewalls open to pull from where else. Make sure you have scanning probably configures. Make sure that you can have Docker and Docker builds, and make sure that you are somehow able to inject credentials into your build servers. So these are the most important things that you can have. So that's it for today. I hope that was somehow helpful. In case there are questions, feel free to contact me. I'm happy to help and give some more insights on here. Okay, goodbye.